All right, today we are diving deep into a technical showdown between two of the heaviest hitters in the cloud graph database world, Amazon Neptune and Azure Cosmos DB. If you've ever dealt with super connected data, you know picking the right tool is a huge deal. So let's get right into it.
But first, let's just back up for a second and ask a really basic question. We're pretty good at storing data in tables, rows and columns, or as JSON documents. But how do you actually database a relationship? How do you build a system where the connections between your data points are the most important thing? Well, that's the exact problem graph databases were invented to solve.
And this visual, it just nails where they fit into the bigger picture. You've got your relational databases for transactions, your document databases for flexible data, but graph databases, they are purpose-built for what we call relationship-centric reasoning. They make the links, the connections between people, products, you name it, first-class citizens. And that is absolutely crucial for modern AI and intelligent systems.
So, here's our game plan. We're going to talk about why these relationships matter so much. Then we'll get into Gremlin. That's the common language they both speak. After that, we'll put the two titans, Neptune and Cosmos DB, side by side, looking at their architecture, their features, and their limitations. And we'll wrap it all up by looking at the core philosophy behind them, specialist versus generalist.
Okay, section 1. Why do these relationships matter? I mean, why did we even need a whole new type of database to begin with?
Well, it really just comes down to solving tough, real-world problems. I mean, think about fraud detection. It's almost never about a single bad transaction. It's about spotting a whole pattern of shady connections. Or what about a recommendation engine that knows what to suggest because it understands what people just like you also bought? In all these cases, the connections aren't just part of the data, they are the whole story.
And that brings us to the one thing that allows us to even compare these two services in the first place, Gremlin. It's the common language that they both understand.
So Gremlin is part of a bigger open source project you might have heard of called Apache TinkerPop. You can kind of think of TinkerPop as the whole framework, and Gremlin is the powerful language you use to walk through or traverse the graph. It's how you find paths, filter out what you don't need, and really make sense of that web of connections.
Now, I absolutely love this analogy here. Thinking of Gremlin as the USB-C standard is perfect, right? Just because your phone and your laptop both have a USB-C port doesn't mean they're the same device. One might be a dedicated high-powered battery pack, and the other is a super versatile laptop with a bunch of different ports. They speak the same standard, but what they're built to do is fundamentally different. Just keep that idea in your back pocket.
And this leads us directly to our two titans, Amazon Neptune and Azure Cosmos DB. Both of them support Gremlin. They have that USB-C port, but they represent two completely different philosophies on how you should build and offer a database service. So, on the left, you've got Amazon Neptune. This is the specialist. It's described as a purpose-built, high-performance graph database engine. Its whole reason for being is to crush graph workloads, and that's it. Then, on the right, you have Azure Cosmos DB, the generalist. It's a multi-model database. Graph is just one of the things it does, right alongside key value, document, and other models. It's the Swiss Army knife of databases.
Okay, so now let's pop the hood. How do these totally different philosophies actually show up in their architecture and how they scale?
This table gives us a fantastic bird's-eye view. Look, both are managed services. Both auto-scale horizontally. That's pretty much table stakes these days. But check out the third and fourth rows. This is where it gets really interesting. Neptune gives you full ACID compliance and supports two different graph models. Cosmos DB, on the other hand, offers something called tunable consistency and sticks to just the property graph model. Right away, you can see they handle data correctness and flexibility very, very differently. Let's drill down on that because it's a huge deal. Neptune's full ACID compliance means it acts like a traditional database. Your rights are guaranteed, rock solid, all or nothing. This is mission critical for stuff like financial systems where you just can't afford any data weirdness. Cosmos DB plays a different game. Because it's designed to be this globally distributed beast, it offers tunable consistency. You, the developer, get to decide the trade-off between strong consistency and super low latency. The catch? You don't get those same strict multi-step transactional guarantees. Okay, so they both have the Gremlin port, but we know the internal wiring is different. Let's look at what that actually means for features and for limitations. Even when you're speaking the same language, little differences in dialect can really matter. So if you run the exact same Gremlin query on both databases, do you get the exact same behavior? Well, not always. This quote from a developer really hits the nail on the head. It's the same exact principle as why you're told not to use select asterisks in SQL. Fetching everything is just wasteful. You always want to ask for only the specific pieces of data you actually need. It reduces network traffic, and it makes everything faster.
And here's where that principle becomes a practical difference. By default, when you ask Neptune for a node in the graph, it gives you back just its ID and its label. It follows that modern best practice. Cosmos DB, on the other hand, might return the ID, the label, and every single property attached to it. Now that might sound like a tiny detail, but when you're pulling back thousands of results, that extra data can have a very real, very negative impact on your application's performance.
And the differences don't stop there. If you're a developer, this is a really important slide. Because of its unique architecture, Cosmos DB just doesn't support some specific Gremlin features. For instance, the match step, which is great for writing more declarative SQL-style queries, isn't there. We already talked about true ACID transactions being out. And the lack of lambda expressions means that some of the more complex graph traversals have to be rewritten in a different style.
So all of these technical details, all these little differences, they all bring us back to that one central theme, this philosophical divide between being a specialist and being a generalist.
And this slide just lays it out perfectly. Neptune is the specialist. It does one thing, graph, and its entire architecture is engineered to do that one thing with incredibly high performance and strong consistency. Cosmos DB is the generalist. It's this powerful, flexible, multi-model platform where graph is a feature, not the whole product. It's built for massive global scale and versatility across many different data models.
So, let's just summarize it all. The bottom line is this. They're both managed, they both scale, they both support Gremlin, but the key difference is their philosophy. Neptune is a specialist, purpose-built for graphs with full ACID compliance. Cosmos DB is a generalist, a multi-model database with tunable consistency. And look, neither one is better, they are just different tools for very different jobs.
And that leaves us with one final question, and this one's for you to think about. When it comes to your own connected data, which philosophy makes more sense? Do you need a dedicated, specialized tool that's been perfected for one specific job? Or do you need a unified, multi-talented platform that can handle it all? The answer to that question is going to shape a lot more than just your database choice. It could shape your entire data architecture.